Hi, I'm Mr. V, and today's lesson is from Illustrative Mathematics. This is the second half, or beginning of the second half of Chapter 1, which is Rigid Transformations. And the title of this lesson is Rigid Transformations. There are three rigid transformations. They are translation, so it has magnitude, and direction. That is length, how far did you go, and what direction did you go. There's rotation, so if you have a point that you're going to rotate a figure around, you have the amount of degrees and the direction, so is it clockwise or is it counterclockwise? And if you're going to reflection, which is where you take a figure and you reflect it across this line. This line of reflection is actually the perpendicular bisector of the pre-image and the image. And we define congruence. Two objects are congruent if you can map the pre-image onto the image with a finite set of rigid transformations. So rigid transformations, there's three of them: rotation, reflection, and translation. The fourth type of transformation is a dilation, and we'll talk about that in Unit 3 when we talk about similar figures and similarity. And today's really an exploration of these types of some different types of transformations. So at the end of class, you should be able to say, well, given a figure and a description of the transformation, I can draw the image, meaning that you have the pre-image. I can draw the image after the transformation. I can describe a sequence of transformations, meaning more than one maybe, that necessary to take one figure onto another. And I know that rigid transformations result in congruent figures. Rigid transformations, your translation, rotation, reflection. So in this first activity, what do you notice and what do you wonder? Some people notice that there are three of these figures. They're all different colors. One is larger than the other. Two are in the same shape, in the same configuration. One is configured a little bit differently. Looks like it might be a reflection across this line. What is this dot O doing here? Some different things. I wonder what this has to do with our lesson. What types of transformations are we talking about to go from S to D, to go from S to M? Why do these have little numbers next to them? These are not numbers. These are like apostrophe, and it means prime. You would say A prime, and that's what you'd look at. And this would be the image. This is the pre-image. This is where you start from. This is where you end up with after a transformation. In fact, there's a picture from the bellwork of the construction marks. You'll notice how the lines, in order to be reflected across this line, you have to be at a perpendicular, and you have to be on equal distance on either side. So if I follow this directly, this dotted line is perpendicular to this one. It's not just anywhere. I'm not going to draw it straight across. I'm not going to follow the grid lines on this isometric paper. I'm going to make it perpendicular, and it's going to be equal distance. That means that this line M is going to be the perpendicular bisector of the image points, the image and its pre-image. We have a GeoGebra activity, and in the GeoGebra activity, just a few things about this. I think I'd leave you a video of how this works. Down at the bottom, there's a video that shows how this works. So I'll only show you one thing, and that is that if I have a directed line segment that is this vector, we call it a vector, we call it a directed line segment. I think they name it a vector in this thing here. They call it a vector, which is a directed line segment. It has length and it has magnitude. How long is it? I mean, that's the magnitude. And direction. Which direction is it going? It's got a tail and a head, and that's the technical term for it. It's kind of like walking a dog. Which direction is it going to go? Where do you start from? Where do you go? So I could move this figure by this directed line segment. This directed line segment doesn't have to be attached to the figure, and you can watch that. I'm going to use the tools of transformations. The ones we will use are reflection, rotation, translation, and later we'll use dilation. We're not going to use these two. But if I were to go translate by a vector, I'll select the figure, and I'll select how far it's going to go. And then I can change the color of this as well. So if I wanted to change the color, I can do that. And you can watch the help video if you want to know more about how to do this. And you should. And also I want you to recognize that if I were to change this direction, I can make it go up a little bit. I can change it. I'm changing the direction and the magnitude. And By doing so, it changes this. We tried doing this by hand. It says to reflect this line across the line Y. And to do that, you maybe find it helpful to draw lines that are perpendicular to line Y. Well, perpendicular is going to be straight across, so I'll go like this. And to do this point, and you can do each of the vertices and do each point like this. So if I did each point, I'm going to go 1.5 of these diamonds to get to this point. This would be this point here. And it goes like this, and let's see, to longitude. Anyway, you'll have this figure, something like that. And you could do each of the points using a line that is perpendicular to Y and the same distance on either side of this. After doing this by, let's see, we did this by hand. Right, here we go. On this fellow, we did this by hand. And, not this one, excuse me. Sorry. Here, we're going to do this using the program. And I'm going to show you these steps for doing this for point D. And you can play this back at your own speed so that you can see what's going on. First thing I'll do is click on this double side. I'm going to go and create more tools, a line that is perpendicular line. Well, it's perpendicular to what? Not perpendicular to this. I want it to be perpendicular to line AB. And this line is perpendicular, and I need to put it somewhere. I want it to be connected to D, so I'll put it on D. And then when we make a circle tool with our center at this intersection, this will give me a second point that is the same distance away from this line, that is perpendicular to this line, same distance as D is. And I can rename that point as D prime. As D prime. I think I have a video of this somewhere. Anyway, this point, if you were to look at it, is a reflection across this line. So if I move this, you see how it stays the same way, same distance, no matter where I put it. And this is because it's constructed this way. It doesn't matter which side of the line I'm on, it's going to be the same distance. If we construct point C the same way, we have a segment that is reflected across this line. We can also do this same reflection with a tool. And I'm going to show you that. So instead of having to do each, I want you to know where it comes from, but I can change this figure. I can reflect this entire figure using a tool, and that would be a transformation tool. To do a transformation, I'll delete this, you need to define the transformation. We're going to do a reflection. And it tells you, choose the line of reflection. So we'll do that here. And then we have to choose some object. So I'm going to choose this entire thing, and I'll reflect it across this line. And there it is. If I move the line around using point A, so move the line around, you can see that this is a reflection. It's on the perpendicular this is the perpendicular bisector of the image and its pre-image. The pre-image and its image. You see those things match up. And this does all of the work of the previous activity with a tool from a transformation tool. All right. Does order matter? There's an activity here where you can check out the order and see if it matters. And the bottom line is that sometimes it matters. So sometimes it results in the same figure, but often by reversing the steps, it does not. So these are not reversible. You need to pay attention to the order. What did we learn about rigid transformations? We learned two objects are congruent if you can take the first image, the starting image, and get it to the second image with rigid transformations. So you can map the pre-image onto the image with a finite set of rigid motion transformations. We learned that the transformations that are rigid are translation, rotation, and reflection. And we will be looking at those in future lessons. So don't get too excited if you didn't absorb everything from this lesson. The final thing is there's a reference document. And if you were to open this reference document, you should make a copy. When you make a copy, you need to keep this in a place where you can get at it. It is important. We will use it throughout the course. It has, you can see this is Unit 1, and there's a lot of words and different things. And then it goes into Unit 2. There are some theorems, there are some corollaries, some assertions, some definitions, some different things. And if you look at the next page, it says here, add this to your reference document. Now, I did this first one for you, where I typed in the words. A rigid transformation is a translation, reflection, or rotation, rigid motion, or any sequence of the three. And rigid transformations take lines to lines, angles to angles of the same measure, and segments to segments of the same measure. Okay. Another one to add to your thing is congruence. One figure is congruent to another if there is a sequence of rigid transformations, the translation, rotation, reflection, it takes the first figure exactly onto the second. And that is called a rigid transformation. Last thing here is the cooldown. In the cooldown, you're supposed to reflect this across the line. Some people found it useful to draw lines that are perpendicular to this line. To draw a perpendicular line, I will draw it like this, or like this. This is a line that is perpendicular, and this is a line that is perpendicular. And then to find the points that it goes to. So if I were to change color and do that, let's see, this is 1/2 of a triangle across it. So there's one endpoint. This is 1, 2, 1, 2. That would be here. This is going to be 1/2 and 1 1/2. So now when I draw this figure, you can see that it's reflected across it. This is the perpendicular bisector of segment D, of point D prime. It's the perpendicular bisector of A prime, C and C prime, this segment. So each one of these is the same distance across it, and it's perpendicular. And here's a lesson summary. And I'd also like you to fill out the cooldown, which tells me how you feel about the course today. Good luck and success.